Hello, welcome to this lesson. In this lesson, we will classify recurrence relation in terms of order, linearity, and degree. Order, linearity, and degree. When we say order of a recurrence relation, it's just the difference. It's just the difference between the first term or the difference between the last term of the sequence. Let me make it the lowest term of the sequence and the highest term of the sequence. Okay, so a difference between the lowest term of the sequence and the highest term of the sequence. Okay, that's the order of recurrence relation. And linearity of a recurrence relation. Whenever you are given any recurrence relation, let's assume A subscript n, okay, to the power k. So this recurrence relation, this is said to be linear if k is equal to 1. If k is greater than 1, it means that that term or that term, the term A, the term A subscript n is what? It makes any given recurrence relation a non-linear. Okay, so for any linear recurrence relation, all the powers or all the superscripts of the nth term of that recurrence relation should be 1. Just like the polynomial function. You see, when you have a polynomial function f of x, ax plus b, this is what a linear function, because the power of x is what? Is just 1. But if you get any function that's in with the power, let's say x to the power k, where k is greater than 1, okay, then we say that this function is what? Non-linear. Okay, then the degree of any recurrence relation is just the highest index of the highest term or a first term or any term in what? Any given recurrence relation. Okay, it's just the term with the highest index. Okay, just like polynomial function, when you have f of x being equal to ax squared plus bx plus c. You see, the highest term, the term with the highest index is what? Just the first term. Okay, and the highest index is what? 2. This to the power 1 and this to the power 0. So the highest index is what? 2. And therefore we say the degree of polynomial function f of x is what? Is 2. The same thing applies to this. Let's solve examples. Okay, after solving examples, you will appreciate the concept. Okay, so now we are to classify the following recurrence relations by order, degree, and linearity. Okay, so we have first question. So when you consider this, let's check the order. So the order is just the difference between what? The highest term and the lowest term of the sequence. So for question 1, the highest term, you see we have n plus 1 term, then also have nth term. So that will be, the difference will be n plus 1 minus n. Okay, and this is 1. So therefore the order is what? The order is 1. Let's consider the degree. The power is 1. This also what? To the power 1. Okay, so therefore the degree is 1. Linearity, since all the powers or the degree is 1, then we say that this recurrence relation is linear. Okay, so we say that a linear recurrence relation is just a recurrence relation of degree 1. Okay, let's move on to the next question. Now we also have another question. Let's consider the order. You see, we have n plus 1 term, then also have n term. Okay, and the difference is what? 1. That's n plus 1 minus 1 gives you 1. Let's check the degree. We have 4 here, we have 5 there, okay, and 5 is greater than 4. Therefore, the degree is what? 5. Since the degree is more than 1, then we say that the recurrence relation is non-linear. The recurrence relation is non-linear. Now, for the last question, for the order, the lowest term is n, and the highest term is 3, n plus 3, okay? So the difference will be n plus 3 minus n, which is 3. So our 3 will be the order. The degree, you see, we have, this is to the power 1, this term to the power 1, to the power 1, to the power 1. So therefore the degree is 1. And since the degree is 1, it is what? Linear. Okay, thank you.